So this is the ANOVA test, and it is by me, Erin, Elise, and myself, Patricia. So the ANOVA test stands for Analysis of Variance. It is an analysis tool that was created by Ronald Fisher in 1918 as an expansion of the Z and T test. Those tests only were able to account for less than 2 or 3 given groups of data, and so this was created to be used for more than 2 to 3 data sets. And so, like I said, it is an analysis tool. And so what the ANOVA test does is it goes in and it separates the observed variance data into different components to be used for additional testing. So those 2 different components that we separate them into is the systematic factor, which is those that have a statistical influence on the data set, and then those random factors, which are those that don't have any relevance or statistic influence on the data set. And so the ANOVA test is used to determine the influences that the independent variables have on the dependent variables in a regression study. And as I mentioned before, you have to have 3 or more groups of data in order to perform this type of test. So the formula for the ANOVA test would be F equals MST divided by MSE. And so F is our ANOVA coefficient, whereas MST is the mean sum of squares due to treatment, and then we're going to divide that by the mean sum of squares due to error. And so in order to find the MST and the MSE, we can use these formulas to then get those to plug into our ANOVA coefficient formula to get our ANOVA test.
Okay, so when we're talking about ANOVA, we want to know, what does it reveal? So ANOVA stands for Analysis of Variance, and it is used to analyze the difference between the means of 2 or more groups or treatments. We often see this used to determine whether there are any statistically significant differences between the means of different groups. So here's an example. You can see that a test was ran roughly 10 times with 3 different methods, and the results show the means are at the very bottom, and then using ANOVA, we can get the overall mean of all 3.
Right, now let's do an example to see how this ANOVA test can be applied into practice. Let's say I'm working on a research to study the effectiveness of 3 different types of hypertension medicines. So in order to do this, I design a research that has 10 people taking medicine A, another 10 taking medicine B, and the last 10 taking medicine C. Then I will record the blood pressure from these 30 people. Then I find out the mean systolic blood pressure of the 3 groups as shown on the screen. As you can see that there's difference between these mean systolic blood pressures. And now I want to know if these differences from the 3 groups happened by chance or because of the medications. And the ANOVA test will help me answer this question. So then I have my null hypothesis. Mean systolic blood pressure is the same / equal for people taking these 3 meds. The alternative hypothesis is at least one group's mean is significantly different from the others. I choose the level of confidence for my test is 0.05. So for the first step, I'm going to calculate the overall mean of systolic blood pressure, which is just the summation of the 3 groups' means divided by 3, and I got 133. Next step, I'm going to calculate the sum of square between by the following step. So I'm going to take the overall mean minus the group A mean squared and multiply by 10. And I'm going to do the same thing with group B and group C, and I got 350. Next, I will calculate the sum of square within by the following steps. I'm going to take group A's mean minus the systolic blood pressure A1, which is the person 1 in group A. Then I'm going to square it. And then I'm going to do the same thing for the remaining 29 people. And then I add all of them together. So I get 915, let's say. Next step, I will calculate the mean square of treatment, which equals sum of square between divided by its degree of freedom, which is the number group minus 1, and I got 175. Next, I will calculate mean square of error, which equals sum of square within divided by its degree of freedom, which is the number of sample. Here is 30 minus 3, which is the number of the group, and then I got 33.89. So now I am able to calculate f stat by dividing the mean square of treatment by its mean square of error, and then I got 5.16. At this point, I'm going to use the F table of critical value for 0.05 level of confidence with degree of freedom 2 and 27. And then I got the critical value of 3.35. Then I can tell that the F stat is above critical value, which means I can reject the null hypothesis and conclude that there is statistically significant evidence at 0.05 to show that at least one group's mean systolic blood pressure is significantly different from the other. So statistically speaking, the differences of mean systolic blood pressure from the three groups happened because of the medication and not by chance.
Does the ANOVA rely on any assumptions? Yes, ANOVA test assumes that the data is normally distributed and that the levels of variance in each group is roughly equal. It assumes that all observations are made independently, and if these observations are not accurate, then this test may not be useful for comparing these groups. So in summary, the ANOVA is a good way to compare more than two groups to identify relationships between these groups. And then here is our resources.